morning, everybody. My name is James, and I am a data scientist. That means I create computer models of real-world things. Stuff like how long I can leave the dishes in the sink before my partner kicks me out. A few years back, Harvard Business Review called data scientist the sexiest job of the 21st century. And it's quite easy to tell why, right? I mean, look at this peak specimen of masculinity. Purpose-built for solving modern data problems. I've got the hunched back, I've got the hot belly, I've got the spaghetti arms. Hot. It's gonna serve me well when my poor dishwashing skills get me kicked out of home. But, I have gone too far forward. I don't know where I am. Okay. My job involves modelling sound record. No, hang on, I've missed more. Let's go back. So currently I work for the University of Western Australia and the Australian Institute of Marine Science. And I'm helping them to better understand underwater environments. My job involves modelling sound recordings of the ocean, which means I know exactly where the sharks are and exactly when to tell pesky colleagues to go for a swim. When I tell people that I work in marine science, they usually assume that I know a lot about the ocean, I spend a lot of time on boats, and that I will eventually be eaten by a shark. As a scuba diver, that last one might actually be true. No, really, sharks aren't very scary. We love to swim with them. These are a couple of my shark photos that I've taken. The things that I'm scared of are these guys. These are scorpion fish. They are incredibly venomous, and when you actually manage to spot them, they look very, very grumpy. A bit like me when I'm at work, actually. Can't stand them trying to steal my look. But aside from knowing how to fall into the ocean, I actually don't know very much about it at all. I've only been doing this job for about 18 months. Before that, I was doing my PhD, which was looking at Medicare fraud. And before that, a little bit different, right? Before that, I was a biomedical engineer. Now I perv on fish. Changing jobs is a really slippery slope. But actually, I used to get a lot more comments about how smart I must be when I tell people I'm a biomedical engineer than now when I tell them I'm a doctor. I've always kind of assumed that's because people associate biomedical engineers with things like prosthetics and neural implants, and therefore being able to make cyborgs. So remember, doctors might make you well, but biomedical engineers can make you better. I don't actually know anything about making people well either. I'm not that sort of doctor, but my handwriting is so atrocious I just had to become one. Sometimes I like to pretend I'm the life-saving sort. So how did I go from one highly niche work environment to another completely different but still highly niche work environment? That brings us to what I want to talk about tonight, which is how no learning is ever wasted, like how 3 days without washing the dishes results in 5 days sleeping on the couch, and the importance of being wrong. Now, I used to work for a company called ResMed, who make medical devices called CPAP machines for treating sleep apnea. So if you guys fall asleep and start snoring on me, I'll have you hooked up to one of these in no time. But my job was verification and validation. And so I would make sure that the devices worked properly before we sent them off to manufacturing to make millions of them. Sounds like a perfect job for someone who likes being wrong, doesn't it? Sounds like someone you want a bit anal retentive for. I can be that too. But in my team, I was known as the troubleshooter. So if something wasn't working properly, if there was a code problem or the tests wouldn't run, someone would come and get me and then I would fix it. And I was relatively new there, and sometimes people would ask me, how do I know how to solve this already? My answer every time was, oh, I already had to fix this for myself. I made this mistake before. I just fucked it up faster than you did. Being wrong lets us get better, as long as we're willing to accept that we're wrong and learn from it. So to the best of my knowledge, I never released anything with any bugs in it. I had lots of processes in place to catch my mistakes before they became problems. And doing that has meant that I can learn things quite quickly. And that's a useful skill. That's led me to where I am today in a job I know nothing about. So for my job, I put microphones into the ocean. We call them hydrophones. Geophones, hydrophones, we're a real imaginative bunch, aren't we? And using these microphones, I record sounds from the ocean. And from that, I apply algorithms like machine learning and other things to learn things about stuff like what animals are living on our reefs, which of our reefs are healthy, and which of my scuba diving buddies are gossiping about me behind my back. Using models to keep track of marine environments through hydrophones is really effective because they're a lot cheaper than similar technologies like cameras, and they can cover a wider range. Cameras are very visually limited in the ocean, whereas we can hear from further distances, which helps us scale up the monitoring without needing to send fleets of bearded scuba divers out. Using acoustic recordings for understanding this is a fairly new field. While the ideas have been around for quite a while, it's only in the last 10 years or so that technology's become available to actually make this a plausible use case. And so it's been really interesting for me, coming from a medical research background, which is quite a well-established field. We have a lot of rigor goes into planning because, if we make mistakes in medicine, there are big consequences. Sadly, not everyone cares about consequences. Most of us do. And so we've been doing this sort of thing for a long time now, and our processes are quite thorough, and we try our hardest not to let mistakes slip through. Marine acoustics, on the other hand, is kind of like the Wild West. Them darn critters is making noise again, let's go stick a microphone on them. And some things work fairly well. There's been a lot of good advances in things like species recognition, for example. Other things are working less well, and that's kind of been the focus of my work. So one of the things that we've been trying is using recordings of the ocean to grade things like the health of reefs. So comparing healthy versus unhealthy environments. And from early research, it seemed like we could use a branch of algorithms called ecoacoustic indices, which summarize the sound recordings and help us to learn whether things are healthy or not. And it makes sense, right? If there's fewer fish and shrimp on a reef, you'd expect to hear different noises and just have a generally different vibe to the soundscape, which might tell us what's going on there, without having to necessarily say, these are the species we're seeing and how many of them there are. But when I started looking at the indices, I was seeing a lot of this Wild West kind of behavior where people were just going and trying things out. I wasn't seeing the same sort of rigor in testing for whether things were appropriate as I was used to. So I got my current job because my skills are fairly applicable across fields. Turns out it's pretty easy to be wrong no matter where I go. So I started applying some of my processes to finding mistakes to these techniques. And basically that meant trying out a whole heap of different things and seeing if what I got was what I expected. It turns out that by changing the parameters of these algorithms, you can get quite different results and sometimes change the interpretation of the results. So parameters are values used within an algorithm's process that people set at the start to change how it works. So it's kind of like setting the timer when you put some toast in, set the timer for how burnt you want it, right? So we used an index that measures the diversity of sounds and compared midnight to midday across a bunch of different sites with different settings for just one parameter. And this is what we found. At low parameter settings, it looks like midnight has more diversity than midday, whereas at high parameter settings, it looks like midday has more diverse sounds than midnight. And obviously this isn't ideal because you can change your interpretation just by tweaking this parameter. And it means we need to therefore carefully select the parameter, make sure that it's actually ecologically relevant to the question. But this isn't always easy because the relationship between the parameters and the outputs isn't as straightforward as that between a toaster and its timer. And sometimes a lot of people aren't trying, like they'll just take the out-of-the-box setting, whether or not it's appropriate. Does this mean that the work that's been done so far is useless? Not at all. This is often actually the way that science works. People will have ideas and try things out, and sometimes the hypothesis will turn out to be true, and sometimes it won't, and sometimes we'll make mistakes along the way. But doing this means we can figure out the next step. Sometimes we wouldn't have known what step to take at all without trying things out. And I think people work this way too. I certainly never expected to be working in marine science, but trying stuff out has led me here and I love it. It's not always easy to try things because mistakes are scary, right? We don't like them. There are also times when you really have to get things right and it's important not to make the mistakes. But generally, my encouragement to you all is to try some stuff out, let some mistakes in, and maybe you too can have the sexiest body, job, of the 21st century.